In this video, we will talk about reviewing some properties of equality and writing two-column proofs. Objectives are we use properties of equality to justify reasons for different steps, and write two-column proof. So before we do all of that, we have to understand the algebra properties of equality. So I'm going to give you algebra properties, and then I will also give you some geometric properties that we are going to use it. So let A, B, C be any real numbers. So the first property that we have is addition property. Okay, the first one is addition property. What is addition property? Addition property is if A is equal B, then A plus C is equal B plus C. Second, subtraction property. Subtraction property, if A is equal B, then A minus C is equal B minus C. Third, multiplication property. If A is equal B, then A times C is equal B times C. Number 4, division property. If A is equal B, then, okay, before we do then, since it's a division property, if A is equal B and C is not equal 0, then A divided by C is equal B divided by C. This C is not supposed to be 0 because 0 in the denominator means undefined. Reflexive property. And this is the property that we use in the geometry. So I'm going to give you a separate example for this reflexive property. It's A equal A. So anything equal to itself. 6, that's a reflexive property. Another geometry property that we use is symmetric property. Which is if A is equal B, then B is equal A. And all I did in the symmetric property, I switched the places. You see, A equal B, then B is equal A. 7, transitive property. This is also the one I'm going to give you example for geometry. Transitive property. Transitive property, if A is equal B, and B is equal C, then you know then A is equal C. 8, substitution property. Substitution property. If A is equal B, then B can replace A in any expression, Okay, now I'm going to give you another property. That's a distributive property. Distributive property. For example, I have A, B plus C equal AB plus AC. What happened here? I'm distributing this A multiply with B and A multiply with C. The same way we can say AB minus C is equal A multiply with B, which is AB. Positive A multiply with this negative C, it's going to give me a Cn minus sign. So that's a distributive property. Let me give you, before we start examples, I want to give you properties of equality for geometry. So those are reflexive property. I said that up here on the top, reflexive property. It means in angles, if you have angles and you're using reflexive property, it means measurement of angle A is equal measurement of angle A, which means anything is equal to itself. Then in the segments, I can say AB segment is equal AB. Then we have a symmetric property. Symmetric property, for example, if I have measurement of angle A is equal measurement of angle B, then angle B is equal angle A. I just switched their places, and that was symmetric in the top too, if you guys pay attention right here. So symmetric, you switch the places, reflexes equal to itself. Then we have for the segments, we can use the same thing. If AB is equal CD, then CD is equal AB. I switch them. Then we have a transitive property. We have if measurement angle A is equal measurement of angle B, and measurement of angle B is equal measurement of angle C, then measurement of angle A is also equal measurement of angle C, which means B and B cancel. The segments, the same thing. If AB is equal CD and CD is equal EF, then AB is equal EF. Again, CD, CD cancel. So these are my properties, and now let's do the examples. And I'm going to use the same property. So this is my example number 1. It says solve 5x plus 12 equal 47. The question is asking, give a reason to justify each statement. Okay, so I'm going to give you statements and reasons. Statements, and that's how you do the 2-column proof thing. Statements in reason. 5x plus 12 equal 47. That's given. The reason is given. Then 5x equal 35. When they give you a statement like this, you have to think about it. How did I get 5x equal 35 from this given equation? So you can tell I subtracted 12 both sides, and I got 47 subtract 12 is giving me 35. 5x is staying the same. So it means I used a subtraction property. Subtraction property. Then I have x equals 7. How did I get x equals 7 from 5x equal 35? I divided 5 both sides, which means that's my division property of, this is subtraction property of equality. I didn't write that. Then I have a division property in here, property of equality. Okay, let's do another example. I have solve 7x minus 10 5 plus 3x equal 2x. And again, give a reason to justify each statement. That would be the same thing, okay? So let's do statements and reasons. So I have 7x minus 10, 5 plus 3x equal 2x. What they would do, sometimes they give you statements, you have to write the reason. Sometimes you have a reason and you write statements. So both ways. This is given. Now next one is 7x minus 50 minus 30x equal 2x. Now what happened here, that parentheses are gone and I got 50 and 30x. What they did, they distributed this 10 and 5 and 10 and 3, right? So negative 10 times positive 5 is negative 50, negative 10 times positive 3x is negative 30x. So what happened here? It's distributive property. We use distributive property. Distributive property. Next step, what happened here? Negative 23x minus 50 equal 2x. Now 2x is the same place, but something happened here that I got. 50 is the same, but 30 and 7, what happened between them? Since both of them are like terms, so I subtracted 7 from 30. And the bigger number keep the sign, so that's negative 23. So that's what happened. So we did what we did, combine like terms. Okay, next. So I got negative 50 equal negative 50 equal, and if I do 25x, what happened here? So if you see the column, this statement, you're going to only look back to the previous step. You don't go all the way back, but just the previous step. So what happened here? 50 is in the same place, but 23x and 2x, they changed. So what happened? They added 23x both sides, because 23x and 2x are like terms. And jumping over the equal means you have to use opposite operation. So I got 25x, which means what happened here? Addition property. Because I added 23x, addition property of equality. Then I have negative 2 equal x. What happened here? I divided 25 both sides, which is a division property of equality. Okay. Now, let's see. I'm going to move this back. Down there so I can have enough space for another example. Okay, here is another example that something like more like a geometry. Okay, so now we have they are giving me statements and reasons. Sometimes statements, sometimes reasons. Okay, so in this case, this is what given. Okay, so CG is equal MN. So the reason, this is already given. Okay, now they said MN is equal CG. So what is this? What is the reason for this? What happened here? You see, I only did the switching the places, and switching the places was symmetric property of equality, if you remember. So instead of this, I'm going to write here symmetric property of equality. That was the reason. Okay, let's do part B. When I have a question mark, then it means this is not given. That's what they are asking. Okay, so this one they are asking me. Or maybe I can use a highlighter for this. So this is what they were asking me. Okay, let's go back. Part B said M measurement of angle P is equal measurement of angle Q, and they already said it's given. Then it said measurement of angle Q is equal measurement of angle B, which is also they are telling me it's given. Then they said measurement of angle P is equal measurement of angle B. Then they said, what is this? So if you pay attention, what happened in both of these columns are these statements like angle P is equal Q, Q is equal B. Then Q and Q, they cancel out. I'm left with P and B. And if you guys remember, that was a transitive property of equality. So this is transitive property of equality. Okay, I'm going to highlight that too. Okay, let's see, go back here for C. C is measurement of angle 1 plus measurement of angle 2 plus measurement of angle 3 equal 50 degrees. And they said this is given. Then we have measurement of angle 1 plus measurement of angle 2 is equal 43 degrees. And they are asking me, what is this? Then we have 43 degree plus measurement of angle 3 is equal 50 degree. And they are also, I mean, this is what I got at the end, right? So if you look at it, what does this mean? What happened here? Angle 1 plus angle 2 is equal 43, right? And then 43 plus angle 3 is equal 50. So if you pay attention, all we did the substitution property, right? We all did substitution property. For angle 1 and 2, this one is equal 43. So what I did, I plugged in 43 for angle 1 and 2, angle 3 equal 50. And that's what happened here. Okay. Now here is another question about two-column proof. So we have a two-column proof given in measurement angle 1 is equal measurement of angle 3. And we have to prove the measurement angle BAG is equal measurement of angle EAC. So before I do anything, I make sure the figure is marked with the given information. So the given information that I have is angle 1 is equal to angle 3, and we have to prove BAG. And you can tell angle 1 is equal to angle 3 because they have just one line for both of these angles, which means they are congruent. In angle BAG, so this is angle BAG right there, that's angle BAG. Angle BAG, angle 1 and angle 2, angle 1 plus angle 2 will give me BAG. This is something, okay, this is A and that's B. Okay, so you can tell that like angle 1 plus angle 2 is going to give me BAG. Okay, so now they said BAG is equal EAC, and this is what we have to prove. So I'm going to go this in green, the EAC. So this is E, A, and C. So I'm going to make it darker so you can see, you guys can see it. Okay, so EAC and BAG. If you guys closely pay attention, this angle 2 is a common between these two angles, right? Between BAG and CAG. So let's start proving all the information. We're gonna make two columns. So I'm gonna do it in probably this color. I have statements and reasons. Okay, number one statement. What if the first of all you're going to write it down whatever is given. So measurement angle 1 is equal measurement angle 3, and that's given information. Number two, like I said, whatever you can see, that's what the statements are, and you just have to give them reason, like reflexive property, transitive property, symmetric property, substitution, multiplication, division, addition, all of those. Okay, so I know BAG is 1 plus 2, and I already told you guys this angle 2 is common between both of these two angles. So I'm going to say angle 2 is equal angle 2. This means that's a reflexive property. When something is equal to itself, so that's a reflexive property of equality. Number 3. Okay, now again, angle 1 plus angle 2 is equal angle 3 plus angle 2, because that's what exactly they said. BAG is equal EAC. So BAG is made up of two angles, which is 1 and 2. So I can say angle 1 plus angle 2 is equal, and they said EAC, so EAC is 2 and 3. So measurement of angle 2 plus measurement of angle 3. So what is this? This is, if you guys pay attention, that's addition property of equality. So I'm adding, you see, 1 plus 2 and 2 plus 3, that's addition property of equality. Property of equality. Number 4, like I said, angle 1 and angle 2 is equal BAG. The addition of angle 1 plus angle 2 is equal measurement of angle BAG. And I also know angle 3 plus measurement of angle 2 is gonna give me angle EAC. So what is this? And you we did this in another video. That's angle addition postulate. This is angle addition, like angle measurement angle 1 plus measurement angle 2 will add up and give me BAG, angle BAG. This is called addition, angle addition postulate. So this is what the angle addition postulate. Okay, number 5. If that's what it is, then we can tell the angle angle BAG is equal. We proved it, that measurement of angle BAG is equal measurement of angle EAC, and the reason is substitution property, right? So it's a substitution property. Write it down here. Substitution property. Like we are substituting 1 and 2, addition of 1, 2, and we are substituting BAG, and we are substituting 3 and 2, and we are doing EAC. Like, do you see in number 3? Like angle 1 and 2 equal angle 2 and 3. So angle 1 and 2 is BAG, which is right here. Angle 2 and 3 is equal, 2 and 3 is equal EAC, which is right here. So I am substituting. So that's a substitution property. If you guys have any questions, please feel free to comment below. I will give you specific examples, the one you are asking for. Please, if you like the video, hit the like button and subscribe. Thank you.